Welcome Science 10. This is the FM3 package, and in particular we're looking at the balanced versus unbalanced force assignment that you have. So it's the one that has the three little cars on it, the boxes, and this flip side. And at the top there it tells you to look at these two pages here. So what I'm going to do is look at those pages, discuss a few things, and hopefully it'll make more sense than just simply you reading through it. So the first page, it's referred to as state of motion, and we look at Newton's first law, inertia of mass, state of motion, and balanced and unbalanced forces, which is what the assignment deals with. So first of all, looking at inertia, it's the tendency of an object to resist a change in its state of motion. So if something is at rest, it's going to stay at rest. If something is moving at a constant speed, then it should keep going at a constant speed unless something interferes with it. So what is that meant by state of motion? The state of motion is defined by its velocity, which is basically speed in a specific direction. That's what we have there. So inertia, a tendency of an object to resist a change in velocity. So if you're not moving, there's no other force acting on it, and no unbalanced force, and you'll see what I mean by unbalanced in a bit. It will remain at zero velocity, so such an object will not change its state of motion unless acted upon by an unbalanced force. However, something is moving with a velocity of 2 meters per second, and earlier we looked at what uniform motion was, constant speed, or constant velocity, which is a speed with a direction. So 2 meters per second east. If there's no other unbalanced force, it'll just simply keep on moving. If there's a force, another unbalanced force involved, it'll change, but otherwise it should stay like that forever. Such an object will not change its motion unless acted upon by an unbalanced force. As learned in earlier units, an object that is not changing its velocity is said to have an acceleration of 0 meters per second squared. So in other words, acceleration, it's not speeding up, it's not slowing down, it's simply going at a constant velocity. So we could also say that inertia is a tendency of an object to resist accelerating. Now in some physics labs you have a device that minimizes the friction, because of course you know in real life things come to a rest because they're gliding on the road or on a table because there's friction on the table. But if you were to minimize friction by using an air track, which is very similar to an air hockey game, and you're familiar with that hopefully, of how a puck will go back and forth, it seems to just go at a constant speed and not slow down. This is what mimics that. So if you give this a little push, it just keeps on moving back and forth with a constant velocity in one way and a constant velocity in another way. So it's a trick to minimize the friction between the table and the object itself. Another interesting demo on this site is this rocket sledder. If you click to that, you can take a look. Here we have a sled during winter time. There's two forces involved here. There's gravity pulling it down, and of course the sled isn't accelerating downward because the ground is pushing up on it. So if we take a look here, gravity's pulling down, which gives the sled its weight, and we have what is referred to as the normal force pushing the sled up. And these are equal and opposite forces, so they balance each other out. Now if I put a force in a particular direction, it's unbalanced. There's no 30 Newton. Here I have, the unit for force is newtons. Here I have a 30 Newton force. Nothing's going against it, so this thing's getting faster and faster and faster and faster and faster until I ease up on the force. And what's interesting, if I get rid of that force now, it was moving, it accelerated using my 30 newtons force, and it's going to keep on moving. It doesn't stop. It keeps moving at constant velocity because nothing's acting against us. But of course in real life we have air drag and we also have friction. So you can see there the snow eventually causes it to slow down until we stop, and then it's zero. Okay, so if you leave that friction on, and if I try to accelerate the sled, so 20 in this direction, 20 in this direction, so it's balanced, doesn't move. It's at rest, there's no unbalanced force, so it stays at rest. 30 It looks like the maximum friction force is 40, or maybe it's 50, I'm not sure here. 50, nope, 50 still not enough. 60, yes. So the maximum force of friction is 50 newtons. So if I apply 60 newtons, 50 will cancel with 50, leaving me with 10 newtons of force to the right. So the sled will gradually get faster and faster and faster and faster. And if I supply even a larger force, 50 in one direction, 80 in this, that gives me a net force of 30. So I can get faster and faster and faster until I get to the speed I want, then ease up until I balance it, 50 and 50, and it moves at constant velocity. Because my up and down force is balanced, my left and right force is balanced, so it's going to keep on moving just like it was moving, which is what that law of inertia says. If an object is moving with constant velocity and no unbalanced force is acting, then it keeps on moving with constant velocity. Now if I get rid of this applied force, oh, there's an unbalanced force of 50 newtons pushing against me, so it's eventually going to cause it to come to a rest. Okay, so that's a really cool demo. I suggest you go on here and play around with that. Adjust certain things. You can adjust the weight of the sled too. See, making the weight bigger, which means it's counteracted by a larger force pushing up on it. So play around with that. It's really cool actually. Check your understanding. Here you have a guy hitting a golf ball. It's a mini golf course, and you have weird things like this. So this is a bird's eye view. You hit the golf here, and it's in a circular rim, so the ball goes around like this. And on exiting, will it go through path 1, path 2, or path 3 and keep going in that circle? And there's a little animation here to give you a hint. And it's a truck carrying a ladder. If all of a sudden the truck comes to stop, the ladder keeps on going in the direction it was going, at constant speed. So that should give you a hint. The ball circles around, circles around, circles around. And this point, the ball is moving to the right at this point. So if I get rid of the circle part to change its direction, it's going to keep on going. So number 2 is the right answer there. And one final question here. A 4 kilogram object is moving across a friction-free surface with a constant velocity of 2 meters per second in a particular direction. Which one of these forces is required to have it keep going at constant velocity? While looking at that sled there, I don't want an unbalanced force because it'll change my state of motion. So the answer there is actually 0. If it's moving at constant velocity, nothing's interfering with it. If I was to apply a force, it would cause it to change, no longer be constant velocity. So the answer is 0 newtons. Okay, so that's the first page. We'll come back and look at part 2, more detailed, looking at these forces. Okay, we'll see you again.